Welcome back to Video Talk. Today we have two wonderful people, two wonderful guests, and very important things and very interesting things to say.
Leslie Gordon.
Kirk Kwiatkowski.
Leslie, can you tell us something about yourself first?
Yes, I'm a retired geologist. I worked for 37 years for the U.S. Geological Survey. Mostly did teaching for the first half of my career, teaching teachers about earth science and how to include it in their curriculum. And then the second half of my career was kind of the opposite. I used the same skill set, but for an opposite purpose, and did public affairs and tell people about what we did at the USGS.
So you're very interested in, since you are a geologist, you're very interested in rocks, gems, minerals.
Rocks, minerals, you name it, I love it. And I just never grew out of it.
And you belong to a lot of clubs.
I do. I belong to all of the clubs on the peninsula, in the San Francisco Bay Area. The San Francisco Gem and Mineral, the Sequoia Gem and Mineral Society, which is in Redwood City, and the Peninsula Gem and Mineral Society, Gem and Geology Society, excuse me. EGGS is in Los Altos. So all of the Gem and Mineral Societies on the peninsula I belong to.
And you?
I'm a member of the Gem and Mineral Society of San Francisco, and I teach there. And
What do you teach?
I teach the faceting class, the lapidary, and some of the silversmithing. Hello, my name is Kirk Kwiatkowski, and I've been a member of the Gem and Mineral Society for the past 8 years. And yeah, just recently I started doing the teaching of the faceting class. I've been studying that for about the same amount of time. And ever since the beginning of it, I just loved it so much. The precision, the angles, the patience that it's needed to get that brilliant gem that everyone is looking for. So then we put it in the machine, and then we select the height and the angle. So the angle is set back here, and then you're selecting the angle, and this relates to how the light is going to bounce back up into the top of the stone, the crown. So from this diagram, you set the angles. So the first angle was 44. So you set it back here on the 44. And then here this is the index gear. So this is going round and round and giving you each face, each facet. So then you don't want it to go too fast, because then it enhances the scratches. So then, and then I'm getting the small facet, and then I go opposite to get the balance, and I go for that one, and then I go the 90 degrees from that, getting that one, changing it again, and going for that one.
The subject of today, if you haven't understood it yet, is rocks. Rocks, gems, and minerals, and how they're formed. So we have the best person here to ask these questions. So what are minerals, Leslie, and how and where do minerals form?
Minerals, rocks are made of minerals. That's the most simple thing that I can say, is rocks are made of minerals. If you take a rock, you look at it, and it's got all these little spots and dots all over it. Those are minerals. Rocks are made of minerals, just like a chocolate chip cookie is made of chocolate chips and whatever else you put in and bake in a cookie. Nuts, flour,
Not a great
sugar.
baker, but a great geologist.
Exactly. Thank you. Thank you. Save me on that one. So rocks are made of minerals. Minerals are formed all over. We look at the Earth in terms of plate tectonics. We have plates that go crashing towards each other. We have plates that go away from each other. And we have plates that, here in California, we live on what's called a strike-slip fault. It's a plate, two plates slide past each other, the Pacific plate and the North American plate, with a lot of little bitty plates in between. And rocks and minerals both form at the junction. And we know, a lot of scientists will say, well, or a lot of people will say, well, how do you know that? We look at the minerals, and we look in the laboratory, and we know the temperature and the pressure that minerals are made in. So we figure, well, if we've got this kind of mineral, it must have been made under these temperatures and this pressure. And we know that in a plate tectonic setting where we're going to find high pressure and high temperature.
And analyzing also the texture, the components of these rocks, you can understand when, the time when they were formed, and why it's so important for geologists and scientists in general.
That's correct. And usually it's because as geologists, we want to know how the world was built, how it was put together, and how it works. And we like to know just kind of like what plate tectonic setting, how does it work? The key to the present is usually the key to the past. So we know that things that are working today, they probably worked the same way in the past. And that's what we want to know.
Why minerals and rocks are so important? Well, we don't think about it because when we talk about nature, we generally look at nature as trees, vegetation, flora. But think about it. We stand on rocks, and rocks are so important, actually maybe more important, because without rocks, nothing else can grow on it.
That's correct. We live on a planet made of, the outer crust is made of rocks. We not only have rocks under but our homes, whether it's the ceiling or the gypsum wallboard or the concrete, whatever, the concrete slab is all made out of rocks. Our bodies are made of rocks and minerals. The whole ashes to ashes things is quite literally, or dust to dust, is quite literally correct, true. We will all go from dust to dust. We were created, the things that are in stars today, things like elements such as hydrogen and helium, are the same things that are in our bodies, and we will be returned to those.
And this is really true. Just think of the calcium that we have in our bones, magnesium and so on. Those are elements that you can find in nature everywhere, right?
That's correct. And in fact, I tell people, like, you know, those minerals and vitamins you're supposed to eat? Well, these are the same. What's the difference between those minerals and the minerals that are in rocks? Nothing, except you don't want to eat rocks. They probably will break your teeth. Instead, you want to eat things that grow in the soil that came from the rocks, things like broccoli and spinach and carrots, things that grow, get the minerals out of the soil, out of the rocks. Soil comes from rocks, and you get the vegetable minerals and vitamins that way to eat them. So I don't recommend eating rocks. They do terrible things to your teeth. Your dentist won't like it.
So what are the physical properties of minerals, like hardness, density, and so on?
Well, a lot of times we tell people that, you know, you can identify a mineral by not only its color, which is usually the first thing that people look at, you know, because you can see birds and butterflies, they have wings or feathers, this color or that color. But really, that's the worst way to tell apart rocks and minerals. So the first thing I do is when I teach rocks and minerals is I tell people, forget about all of those hardness and cleavage and color and habit and whatever. Forget about those and think about what we use the rocks and minerals for. Think about how we use them in our house and what they're good for. It's the silky feeling that you get from talc that makes it good in talcum powder. Or the color of, azurite or malachite that makes it good in pigments, ochre.
So forget about hardness and all the other qualities and think of what they can give you, right? Also in the house. And you told me once, Elena, look, also the electrical wires are made, or they were made with copper, right?
Exactly. And copper is a naturally occurring element in the Earth's crust. We call it a native element, just like gold. It's found native, natural. It's also found in certain minerals like chrysocolla or turquoise or azurite and malachite. But copper gives it that beautiful blue-green color, and it makes a pink. The metal is pure pink or kind of a, it's pinkish, the metal color, copper color. There you go. So all of the, whether it's the wiring in our house or the porcelain in our toilet bowl, it all came out of a mine. It all came out of a former rock or mineral.
And you are wearing turquoise.
I'm wearing turquoise because I like to match what I'm wearing. I have a turquoise colored shirt on, so I like turquoise. Turquoise is a copper phosphate. And Kurt probably knows a lot more about rocks and minerals than I do, but I love turquoise.
Don't be so humble. You're a geologist. Now we ask Kirk, what is a gem and how you work on them?
A lot depends on just what we have put to it, but mostly it's the rarity, as well as a lot of times the hardness is what we're looking for, but we also work with soft materials. So a lot of the gems are made from the more rare. So it could be the semi-precious, which is like the sapphire, the emeralds, the rubies, and then like the precious, like the diamonds, yeah. And then, but also we very much use like the softer, very common elements as well that can be turned into beautiful things as well. So it's kind of, but a lot of it is dealing with like the hardness. That way we can like do the shaping, the faceting, the, and also it being where you can wear it and, you know, you could bump it and do things, you know, in your daily life with them on without them getting damaged as well.
I heard that tanzanite is one of the most desirable gems nowadays.
Yeah, it's really
and it
rare.
comes only from Tanzania.
Yeah.
What color it has, how beauty it is, and why so much desirable. More than diamonds, it seems.
Mm-hmm. I mean, diamonds are actually more common than people think. It's more of a marketing thing, but there's like probably at least 10 or more rare that, but like the tanzanite, it's like often it can be gray, green, blue, but they often do heat it or color it through a heat treatment to make it that brilliant blue, but some are also that distinct bright blue color.
What are geodes?
And I love amethysts when they grow and
the
inside,
geodes.
and you don't see them, but then you cut it and you see these wonderful, wonderful crystals with different colors.
Well, I mean, it's like that perfect condition within there, as well as like the water elements coming in. So it's growing in that specific environment. And then often, what do you think about in that condition? It's just the heat, the perfect heat, the perfect water. Often, like with some of the mines, when they drain the water out, like some of the crystals stop growing or they start changing because them being within the water was what allowed them to keep living and growing. And
So geodes are easy to find, to be found, and where? Geodes easy to find in California, for instance?
what do you think?
I don't know. The most famous geodes are from Oregon and Utah, Washington, and thereabouts, and some in New Mexico. I don't know of any in the ones you're talking about that are huge, with huge crystals, are from Uruguay and Brazil and South America. And those are places, so like Kirk is right, that it just takes all these perfect conditions all coming together. You need a cavity or an empty space. You need hydrothermal fluids, water that's hot, that has dissolved minerals in one place and deposits it in another place for a certain amount of time, and it leaves it hollow. And then everything else around erodes, and you're left with just a geode, what we call this hollow sphere that has crystals growing in it. If it's completely filled in, we call it a thunder egg, and those are well known from Oregon. Mostly they're hollow, and then we call them geodes.
I saw at Gem and Mineral Society, because you have a vast collection of stones and gems and rocks, and I saw some rocks and some minerals that really have almost perfect cubic sizes.
Well, I think the cube one was probably fluorite, correct? You think?
I think Kirk is correct. And it is a way for geologists to recognize certain minerals or by their crystal form or how they're grown.
I I saw some amethysts. They are hexagonals or almost kind of pyramids looking forms. Why that?
Amethysts are always six-sided shape because it's a type of quartz. So if you see an amethyst crystal, whether it's big or little, it's got six sides. It usually is the actual molecules inside. Amethyst is mostly silicon and oxygen, silicon dioxide or silica, not silicon or silicone or one of those is a silicon is the element, and it's the valley that is near us. Silicone is what we make breast implants out of and some glues. And silica is silicon and oxygen. Silicon dioxide is the same as silica. And that's what anyway, it has to do with how everyone has seen mica, these books of mica that split apart into sheets. And that's because of the covalent bond is more strong within the sheet than the ionic chemical bond between the sheet. And the way a mineral breaks apart is what geologists call cleavage. And that is sometimes, like, even though diamond is the hardest substance, so it's going to scratch glass, it's going to scratch any other things.
Pure carbon.
But it also has wonderful cleavage. So if you hit a diamond with just the right way, you smack it into something, it's going to break really easily. And that's how they used to cut diamonds, is by cleaving them. So the cleavage is how the molecules are arranged, the bonds in between all of the molecules, how a mineral breaks.
Oh, another thing is a mineral that I really like, a rock that I really like, I saw, is these are rocks with rutile, and they have like needles, golden sparkle needles, and I found out that those are titanium dioxide. It happens to all the gems that can be affected by titanium, or only certain rocks?
It's most common in certain rocks, like mostly the clear rocks that you can, or minerals that you can see them in. So we talk about a rutilated quartz, which because and rutile, those are like the tiny little golden needles, are actual crystals that are growing inside a quartz crystal. And that's what those needles are. They're beautiful, I agree. It looks like hair, golden hair.
Like golden hair, yes, that's right. So minerals and light. Minerals are so beautiful because they reflect light. There are some incredible rocks. They look very ugly, and nobody would pick them up unless they put it under UV light. And what happens?
So here we have a display showing some of the fluorescent minerals that are here in California. Now during the day, when you walk past them, they may look like brown, gray rocks. But at night, illuminated with UV light, you'll see them fluoresce in shades of red, orange, green, yellow, purple. And this is a great way to identify minerals because they'll all fluoresce at slightly different colors.
It's the presence of phosphorus, and then when you put the UV light, like especially the black lights, you can really see it, that it excites the particles, and then they start glowing from the light.
That's exactly right. What Kirk is saying is that probably the most famous place in the U.S. for fluorescent minerals is near Franklin, New Jersey, a place called the Sterling Mines. But those are all flooded now, and they're full of water. The minerals that were there, the calcite, the willemite, franklinite, zincite. Franklinite does not fluoresce, it's just dark black. But the willemite fluoresces, it glows green, bright green. And the calcite is usually a bright pink. And they are amazing. And so if you think of the visible light spectrum, it goes from, everyone knows Roy G. Bibbs, the red, orange, yellow, and green, and blue, and indigo, and violet. Ultraviolet is beyond the violet, so our eyeballs cannot see it or detect it. But sometimes you'll get a UV flashlight. They call them black lights sometimes. And there's long wave and short wave as you keep going down the spectrum of ultraviolet lights. If you go the other direction, there's infrared, which is the heat that people feel from lights, the heat from the sun. The ultraviolet's one that's going to burn you. Anyway, so we as humans see a really narrow range of this whole electromagnetic spectrum. And some things make rocks visible in a different wavelength than what we can see with our eyes.
So how can you spot them during the day then? How can you know that a particular piece of rock contains phosphorus and it can be beautifully lit up in under certain light? So when you pick it up, you don't know because it just looks like another common piece of rocks, right? So there is a way that maybe you can say, oh, this might be fluorescent under the light, UV light.
Usually there's always some other way to recognize a mineral. Like you were talking about the cleavage and the color and the habit and form and so forth and all of those things and whether or not it's magnetic. And usually you're looking for a certain mineral or it's known to occur in a certain place. And so if you're underground and it's dark, it's easy to, or at nighttime, it's easy to use a UV flashlight. During the day is difficult, but you might you're in a place where it's known there. And so you might look for a different habit or hardness or color or cleavage or something, another way to recognize that mineral.
That's excellent, and they are really beautiful. I was amazed when I saw them and said, wow, I didn't know that they existed. I love to hang out at Gem and Minerals, and actually I will come to a field trip with you. I want to say something else. The Earth has over 5,000 species of minerals. But can you tell us about the cycles from the magma, what the cycle and the evolution that made this possible?
You know that after the Big Bang, we had lots of hydrogen and helium, and they fused together inside stars, and that's where most of these heavier elements and things like that, like the Earth, we know that the Earth has a crust, the outer element, the outer rocky crust that we all stand in, and then inside is a mantle, and then a core, and an inner and an outer core, outer and then inner core. And some of those are metallic, like iron and nickel, and they're liquid. And it's all those heavy elements, things like uranium and iron, that kind of fell to the bottom. And the lightweight stuff, all the silicon and oxygen and aluminum, kind of just form this crust, this foam, this crusty stuff on the outside of the planet, whereas heavier elements fell to the bottom, or inside.
Part of it too is like the gravitational, is how the heavier elements were getting pulled to the middle as well.
Thank you.
Yeah.
Yes, I forgot about gravity. How can we forget
So
about
like
gravity?
like the more and more they just started getting more and more compressed, and that was also a big formation from the pressure, and the gravity pulling in is.
Kirk is right.
Okay, so the same process happened to petrified wood because they do not belong to the tree formation, to the wood formation, but they are really stones.
And there is a beautiful petrified forest near Calistoga.
Can you tell us what happens to the
You know, the
wood
process
and
of
then
it.
when it becomes a stone? Because it's quite interesting.
You know, the process, we call it petrified wood, but petrification is the same as fossilization. So this is fossil wood. It's just another name for it, petrified meaning turned to stone. And we take each little cell. If you look at them under a microscope, those little tree rings are individual cells. And each cell is replaced one by one with a crystal of agate or quartz or something, so that eventually the whole log or wood, piece of wood, whatever you have, is turned to stone, cell by cell, but it still retains the original cell structure and look. The same thing will happen in bones, like dinosaur bones. They'll look just like a bone, but they're fossilized. They've been turned to stone.
That's very interesting.
Is it always with the presence of water as well, or not?
Usually, water is a great thing on Earth that goes through it. It's normally warm because deep inside the Earth it's warm, so it'll dissolve minerals in one place and deposit them in another. So there's almost always water and dissolved minerals involved in every kind of fossilization or making minerals.
What about beryl crystals and the most famous is the tourmaline? There are a lot of mines in California, especially in the south. And you know something about it, right? You have a great experience lately.
A little, yeah. There are some tourmaline mines in Southern California. The most famous are the Himalayan mine and maybe the, well, I don't know, but they're very famous. They're well known. Most of the tourmaline. Tourmaline is a family of gemstones that have been used for jewelry. They come all different colors of the rainbow. And I broke my ankle by trying to go to an old mine. You can go to them still. And some of them are still operating. The operating mines, they don't let you in because of OSHA and things they would worry about. But, you know, you don't want to get conked on the head with some mining gear or something. But the old mines that are closed down are old pits or old trash heaps, old dumps, old trash piles are great to pick through for, to see if you can find any more stones. So I happened to be in the San Diego County area a few months ago and broke my ankle because they're all granitic pegmatites.
Did you find anything?
We didn't find anything. I just came home with a broken ankle.
Well,
My buddies found stuff, but not me. I had to cut my trip short, and I just came home. But I don't know. Maybe you know more about Southern California.
I haven't been, but I was going to go on that trip. But yeah, the Ocean View mine was another one really great. They have kunzite there, tourmaline, morganite.
Oh, that's wonderful. We'll talk in the next episode of Video Talk more about going actually rock hunting. It can be a nice holiday trip for the whole family. Thanks for being with us and see you next. Ciao.